Hi, I'm Jamie.
I'm Nicole.
And I'm Juderlin. We're here to share to you a short video about optimization.
As a help to all of you, we've organized the lectures according to what do you want to solve.
So you better sit tight now and listen well to all what we'll say.
What is optimization? Optimization is a process of determining the optimal or best quantity of a variable that will lead to either the maximum or minimum value called as absolute extrema of the given function. To compute for such extrema of a given function, calculus is applied by getting the derivatives of the function. When do we use optimization? Optimization usually deals with the following topics: problems involving maximum revenue, problems involving minimum cost, and problems involving maximum profit. Let us start dealing with problems involving maximum revenue. Given the revenue function, the following is possible to be determined: level of sales that maximizes revenue, the maximum revenue or sales, and the unit price that maximizes revenue or sale. Here's the first sample problem. In producing and selling X hundred units of commodity, the revenue in 1,000 pesos can be approximated by the given revenue function. Let's answer the following questions. At what level of sales is revenue at a maximum? What is the largest possible revenue that the firm can have? And at what price each unit should be sold to maximize revenue? To answer the first question, we have to take the first derivative of the revenue function as well as the second derivative. We use the first derivative to solve for the critical value. By assigning or equating the first derivative to 0, we were able to solve x as 9.8, which means 980 units must be solved. For the second question, to determine the largest possible revenue that the firm can have, we simply evaluate the revenue function by substituting the solved critical value to it. From here, we were able to solve that the largest revenue could be 22,802 pesos. For the third question, just what price each unit should be sold to maximize revenue, we simply divide the maximum revenue by the number of units that needs to be sold. And from that, we are able to solve the unit price as 23 pesos and 27 centavos, the price of each unit that would maximize revenue. Now let's proceed to the second sample problem. The revenue for selling X thousand units of a product can be approximated by the given revenue function, but remember, the revenue function is useful only when X is between 1 to 10 only. You are asked to solve how many units must be sold to maximize revenue, and how much would be its largest revenue. Now, let's try to answer the first question. How many units must be sold to maximize revenue? For that, we have to get the first derivative of the revenue function and use it to solve for the critical value. If we equate the derivative of the revenue function to 0, we will be able to solve for the two critical values of 10 and 4. Since there are two critical values, we need to determine which one will lead to the maximum value. Use the second derivative to determine which between 4 and 10 maximizes revenue. Evaluate the second derivative using the two critical values. R double prime of 4 will have a value of negative 18, and the R double prime of 10 will give a value of positive 18. Since the R double prime is negative at X is equal to 4, then revenue is maximized when X is at 4. This means that the company should sell 4,000 units. Now, to answer the second question, how much will be its largest revenue? This can easily be done by evaluating the revenue function by substituting X with 4. With this, we can see that the largest revenue is 708 pesos. problems involving minimum cost. Given the cost function c of x, the following is possible to be determined: the optimal number of units that minimizes cost, and the optimal number of units that minimizes average cost. Here's the first sample problem involving minimum cost. A company is capable of producing at most 3,000 units of refrigerators. The total cost of producing X units is approximated at the given cost function. How many units does the company need to produce in order to minimize cost? To find the optimal number of units that would minimize cost, start by getting the derivative of the cost function. Solve for the derivative of the cost function. Then use the first derivative of the cost function to solve for the critical values. Since x can't be negative, we consider only x equals 2,000. We take then the second derivative and evaluate c double prime 2,000 to determine if x is equal to 2,000 leads to the minimum value. Evaluate then the second derivative by x is equal to 2,000. We'll see that the cost is minimized when the number of units produced is 2,000. Lastly, we will now show you what to do with problems involving minimum profits. Given the demand d of x, revenue r of x, and cost c of x functions, the following can be determined: the profit function, the optimal number of units produced that leads to maximum profit, and the maximum profit. Here's the first problem. A mobile phone manufacturer is determined to sell its new touchscreen mobile using its demand function given by d of x, which is equal to 5,000 minus x. While considering the cost of producing x units of this model using the cost function c of x equals 1,750 plus 14x, let us answer the following questions. Find the revenue and profit functions. What optimal number of units would maximize profits? And at what price each unit should be sold to maximize profit? To answer the first question, which is asking us to find the revenue and profit function, we solve for the revenue function by multiplying the demand function by x, which is the number of units sold. We then describe what is the profit function by subtracting the cost function from the revenue function. Let's proceed now with the second question. What optimal number of units would maximize profit? We use now then the first derivative of the profit function to solve the critical value, and then the second derivative to test if the critical value gives the maximum profit. Since p double prime x is negative in all values of x, specifically when x is approximately 2,493, then profit is at maximum when 2,493 units are sold. Then, using the demand function, we solve for the unit price that will maximize profit. Each unit now must be sold at 2,507.50 cents each. And now for our final sample problem. White Metabolist is an antibiotic product with monthly revenues and costs, which is described by the given revenue function and cost function. You are asked to determine the following. First, the profit maximizing price and output combination, and second, the average cost minimizing price output combination. To solve the first question, we identify the profit function by subtracting from the revenue function the cost function and use its derivative to solve for the critical value. Test now using the second derivative to determine whether the critical value leads to the maximum profit. Let's divide the revenue function with the critical value to determine the unit price. With that, we can see that the output that maximizes profit is at 1,167 units at 1,067 pesos and 67 cents per unit. And then finally, to answer the second question, we solve for the average cost function so that we could use its derivative to identify the optimal output. Then, we use the revenue function and the optimal output to solve for the optimal price.
So that's what optimization is all about.
We hope that you learn from us.
And thank you for bearing with us.
Bye!